Now we will take some more examples of ball problem. Suppose we have three black ball, two red ball, and five green balls. So how would you calculate probabilities of getting each ball? Means if we have to calculate what is the probability of getting black ball, so how much outcomes of black ball will be there? 3, and total number of events will be 3 plus 2 plus 5, that is 10. So probability of getting black ball will be 3 by 10. Similarly, probability of getting red ball will be 2 by 10. And probability of getting green ball will be 5 upon 10. We can go with another example, like you are having a dice which is having 6 faces, and each is numbered like 2, 3, 4, 5, 6. So if we can ask what will be the probability of getting more than 3 in a dice. So what are the likely events? First list out the likely events. It can come 1, 2, 3, 4, 5, 6. Now you have to find out what is the probability of getting more than 3. More than 3, there are only 3 probabilities, 4, 5 and 6. Total number of probabilities are 6. Total number of events which can happen are 6. So probability of getting more than 3 will be 3 upon 6. So there are 3 times when you can get more than 3 number, 4, 5, 6. Total number of events are 6. So probability of getting more than 3 will be 3 by 6. Similarly, what is the dice problem is again, and what is the probability of getting less than 2? So here you can see there are only one probability of getting less than 1, 2. So the probability of being less than 2 is 1 upon 6. Now we take another example of this is one problem. Typically in probability we can say this is URN problem, and this is a dice problem. So in urn, what is the probability, if we can ask, what is the probability of not choosing? not choosing red balls. So what is the probability of not choosing red balls? What are the number of events? We will count similarly. The number of events are same. That is 10 events. Now, what is the probability? What is the number of outcomes when we will not choose red balls? So there are 1, 2, 3, 4, 5, 6, 7, 8. In eight outcomes, we will not choose red balls. So probability of not choosing red balls, not red, will be 8 upon 10. Similarly, what will be the probability of not choosing black balls? So not choosing black balls will be counted like this: 1, 2, 3, 4, 5, 6, 7. 7 times you will not choose black ball. So the probability of not choosing black balls will be 7 upon 10. And similarly, not choosing green ball will be 5 times you will not choose green balls out of total events. So 5 times you will not choose green ball. So this is the way we can choose. This is the likelihood of an event, and this is not likelihood of an event. In similarly, in dice problem, you can see there are 6 outcomes: 1, 2, 3, 4, 5, 6. So, what is the probability of not choosing 3? Probability of not choosing 3 will be always 1 by 6, because there will be 6 number of events and one time you will not choose 3. What is the probability of not choosing 4? Is similarly 1 by 6. You can ask, what is the probability of not choosing an even number? So 3 times 2, 4 and 6. 3 times you will not choose even number. So probability of not choosing even number will be 3 by 6. So we can count the probabilities of both in both the cases where the events is likely to happen and when the events is likely not to happen. We can mix these probabilities in next chapter. So now we have learned about the earn problem. Similarly, if you want to see in all the cases we are making replacement of balls. It means we are choosing black balls, then we are putting it in it. Number of events will remain same, 10. If you are choosing red balls, then you are again putting the red balls into it and again pick another ball. In replacement of balls, you are always replacing the balls. You are choosing one ball and that ball is again being dropped into the oven. Now, in the case of non-replacement, what will happen? Suppose you have taken a black ball. So, in this one, taking black ball, probability of taking black ball will be 3 by 10. Now suppose if in the second event, if I am not replacement is not done. So you have taken black ball and you have not dropped it again into the urn. So how many balls will remain into the urn? So if you can see, there are three. There were three black balls, one red ball, two red balls, and five green balls. In this event, we have taken one black ball, which probability is 3/10. Now, suppose we are not replacing that ball again. So, what will be the probability of getting?
I win. Only 4 again.
Five. What will be the probability of getting black ball again? Now, you see, when the replacement is not being done, the probability will be 2 by total number of balls now 1, 2, 3, 4, 5, 6, 7, 8, 9. So in a replacement problem, the probability will black of getting black or getting red will be changed. Suppose we are in a replacement problem, what will the probability of choosing red? Here we have taken 2/10. Suppose we have taken a black ball. Now, how many balls are remaining? 9 balls are remaining. So, in this case, if we are taking red ball, the probability of getting red ball will be 2/9. And similarly, probability of getting green ball will be 5/9. So in a replacement problem, you pick a ball but you don't replace it. So there the number of events will be less than 1 comparing to the replacement problem. So in practicality, what you see that there is a replacement going on. In some cases, in the case of dice, there will be always replacement. In the case of choosing ball from a urn, there will be a replacement and non-replacement both. So in next examples, we will come with replacement problems. Now take an example of card problem. So as we know, there are 52 cards. 52 cards. And there are what is the choosing of one card? What is the probability of choosing one card? That will be 1/52. In case of a replacement, the choosing of one card will be 152. As many as times you choose it, pick a card, pick one card. All the time the probability of choosing one card will be 1/52. Suppose you are not replacing, no replacement. In a no replacement case, next time the choosing of a card will be 1/51 because one card will be taken away and it will not be replaced. So number of events which is remaining is 51 only. As we know, what is the probability of choosing one ace card? So in the card, there are 4 ace cards out of 52. So the choosing of one ace card will be 4 by 52. In a fresh card, choosing a ace will be 4 by 50. Suppose you are not replacing that ace card and you are again chasing an ace card. So choosing an ace card without replacement, no replacement here. You have taken away one card, will be, because you have taken one ace card. So number of ace cards remaining will be 3 only. And number of cards will get down to 51. So after no replacement, choosing an ace card will be 3 oblique 51. Similarly, you have got a fresh bundle of cards, and now what will be the probability of choosing a face card? You know, there are 12 faces in a card. Fresh deck, 12 faces are found in a card, in a deck. So, what is the choosing a face of a deck? That will be, there are 12 faces, total 12 faces, and number of cards are 52. Now, once you have chosen a card, a face card, what will be the probability of getting another face card? So here you are not replacing, no replacement. In case of a no replacement, out of 12 cards, one card will be taken out and 11 cards will be remaining. Total number of cards will also get down to 51. So, after no replacement, the probability of getting face card will be 11 by 52. Now this is very important, and we will use these examples in real life problems. Like a card problem, like a dice problem, like a urn problem. ठीक है,
चलो ये खत्म हो गया आज।